There it goes. Okay. Lesson 5. Solving with radicals and exponents. If there is only one x. Okay, so first thing we're going to do, we have two categories we're going to look at. The first category is if there's only one x in the equation, how do you solve? It's a general description. If you see only one x in the equation, what do you do to find x? Starts with an I. You did a lot of this in Algebra 1. I, S,
Isolate.
Isolate. Yes. Okay, guys. Solving strategies don't change. All we're doing is we're adding a couple new things to it. If you only have one x, you isolate x. How do you isolate x? You actually do PEMDAS backwards. Sometimes they call it SAD-MEP. Read it backwards. SAD-MEP. That's how you isolate. You do your order of operations backwards. Okay? Now, we're going to look at how you undo the new characteristics, radicals and exponents. We have to undo them to solve, and so we're going to start very simple. And we're going to, how do you undo radicals and exponents? Okay? Because you can undo add and subtract. Those are inverse operations. You can undo multiply and divide. We are here in the exponent category. We need to figure out how to undo the exponents. Okay? So we're going to start with, right, nothing extra. All I'm going to do is have an exponent, and I'm trying to get to x. How do you solve this? Find the root. Yeah. So I'm going to do this. Ah, very nice. I hear a plus minus. Okay. Which is true. What was the power? The power was 2. I have 2 answers. Degree gives you the number of solutions. But do you want to know why you put a plus or minus here? Sort of. Yeah, negative 3 squared is positive 9, so it works. Both answers check. What about this part? What is the square root of x squared? No. What is the square root of x squared? Almost. You're missing something. No. Even, odd. Okay, why do we have that property? That's why. Even, odd result. Okay? Right? The square root of 9 is 9. It's random that you put a plus minus there. The reason you get a plus or minus is if you remember back in Unit 1, absolute value describes the distance from 0, and that's where you get negative 3 or positive 3. Even, odd. And both of these answers check, right? I can plug them back in and they both work. Do I need you to show me this? No. I just need you to get plus or minus in the right place. Because this is what we're used to doing. Square root, bam, plus or minus. Question.
Is there a reason you have the caret under the...
No, that was, that's not a caret. That was me drawing
Oh, okay.
to what's the next line of solving. And I like to write it as a V because absolute value reminds me that there's a V and I get two parts to it. Okay, so let's extend this and let's try x 3/2 equals 27. I got you, I'll scoot it up. There we go. X to the 3/2 equals 27. We're only in the exponent part of PEMDAS. We are only trying to undo the exponents. And then we'll add a couple other operations. Okay. Maybe. I mean, yes, but... Okay, any choices? Any suggestions? You could use a power of 2 on both sides. Yes. I'm going to hear a couple other suggestions and then we'll write some of them. You could put it in a radical. Yes.
Yeah.
Okay, so I'm gonna do both of your suggestions. Use a power of 2 on both sides, and she said I could put it in a radical. Okay, so this is power root. Okay, so that exponent is really a power and a root. Okay? And Katie said that we could do a power of 2 on both sides. I would like you to use grouping symbols. Okay? When you square both sides of an equation, you are squaring the entirety, not each individual term. You are squaring the whole side. The left side gets squared together. Okay, so power and root, they do cancel out, and we get do not square 27. Right, no calculator, guys. Do not give me numbers that are more than 100. Leave them in exponent form.
Oh, then when you square root, you're going to 27.
And now how do I undo the power?
Cube root.
Cube root. I like to show my operations in red so you can tell what came first. Right, the blue line came first, and I did the red. So I get x to the first power, no absolute values because this is an odd root, cube root 27 squared. Well, that's not an answer. You have to make sure that it's simplified radical form. And so I'm going to write it this way instead. Exponents, radicals and exponents, powers, they're the exact same level. It doesn't matter which one you do first. I prefer to root first because I don't want to square 27. Yes.
Would it be more simple to say 27?
Well, we're not quite done. I'm just moving my square power so that I can see the cube root of 27 is 3, and then 3 squared is 9. 9 is the answer. But you've got to simplify that radical statement. You don't necessarily need to simplify it till you get to the very end, but you do need to check to make sure that you simplify it. Notice I didn't need a calculator, guys. I didn't square 27. I didn't take the cube root of that giant number. You've got to decide what can you do first. Okay? However, I think there's a better way. So you're going to rewrite the problem over here. I would like one step. One step. Not 2. 1. You're allowed to do one thing. Okay. Give it 1 second and then I'll ask you to share. Okay, 2 people think they have it. 3. Okay, Will, what do you get?
You multiply it by the inverse of the fraction.
Yes, but wrong word. Reciprocal of the fraction. And it's not really multiply, it's more like power. use the reciprocal power because my exponent rule says power to a power multiply. And so this does give me x to the first power. And we do get 27 power root. Now you can change the power root combo into something you can simplify. So I'm going to go cube root 27, and then I'm going to square, which we already did that here. Yeah, one step, guys. Exponents is one step. Do I need plus or minus? No. Did I have to square root somewhere? No, I did not. I had a 3 power. There's no plus or minus with a power 3. Okay, so we've looked at how to undo. We've looked at plus or minus. Oh, I just spelled that wrong. Plus or minus. Here's our first example then. Okay, 1/2, parentheses, 2x plus 1 to the 2/3 power minus 1 equals 1. Okay. I added some operations here. How many x's do you see? 1. What are you going to do? Isolate. Okay, give it a try. Isolate x. And then I'll check in with you. Question, Cyrus? One step. How are you going to undo your power in one step? Okay, here we go. Eyes up. First 2 steps. I'm going to 2 steps at a time. What's your first and then your second? Add 1 to both sides. And then multiply by 2. Okay. I guess I can write plus 1, plus 1. Then I'm going to times by 2 on both sides. Okay. You're ahead of me. Hold on. Okay. And 1 step. Not 2 steps. 1 step. An exponent can be undone in 1 step, no matter what the exponent is. What's my exponent going to be? What exponent am I going to use? 3 over 2. Okay, so I already have parentheses, so I'm using brackets just to differentiate. I'm going to do a 3/2 power. A 3/2 power. All right, so then we get 2x plus 1 equals. Okay, you can use scratch paper, evaluate, simplify 4 to the 3/2. So 4 cubed. So I get 2 cubed. So I get 8, right?
Would it be plus or minus 8?
Ah.
Okay, just spell it that way.
It would be plus or minus 8. But why? Because I'm square rooting it. Yes. Okay, it's tricky. It is tricky. What is the power on this first part? Oh, that's a square power. I know I have a cube root in there, but that is squared. Listen, when you have a square and you square root, you always get the plus or minus. The trick is looking at what you start with. I started with an even power, which means I had to square root, which means I'm going to get plus or minus right after I square root. And so you get plus or minus 8. Okay, I'll say it again. I started with x squared. I started with a square, which means I'm going to have to get a square root to solve, which means I'm going to have to end with a plus or minus. Look at our first example up here with the 9. Okay, I started with a square. I had to square root, means I'm going to get plus or minus.
Wait, how did you do, like, can you go down? How did you do, I mean, I know it gets to 16 but...
I highlighted it. A 1/2 power.
How did you automatically?
Okay, hold on, guys. Power 3 root 2. I just converted it to radical form to simplify. Okay, you're not done. You don't have x equals yet. Because there was a times 1/2. Okay. 2x plus 1 equals positive 8. 2x plus 1 equals negative 8. You have not isolated yet. You got all the way to the exponent. You still have to go back and start over and get to x. Careful with that plus or minus. Yeah, that's it. Those are my answers right here. 2 answers. Okay.
Then there's not really a way to make it a lot more complicated.
Maybe, but not really when you're isolating. Just got to make sure you do your operations in the correct order. Okay, let's do another example. Number 2. Go back up. Here we go. Eight plus 2 root 5x minus 1 equals 2. There is a trick in this question. Don't say it, but look for it. There is a trick in this question. So as you are solving or isolating x, see if you can find it. Yeah. You didn't make a mistake. You just missed. You're algebraically, you're fine. Okay. You guys ready for it? Okay. Let's go ahead. I can isolate. There's 1x. Minus 8. Don't erase. You're not wrong. Don't erase. And I get 2 root. Okay. I'm going to divide by 2, which is actually the same thing as multiplying by 1/2. Hold on. Here it is. Okay. I'm going to square. You're feeling pretty good. Hold on. I'm going to show you. Hold on. I'm going to add one. Yeah, you're not wrong, guys. I said it's a trick, okay, because it's hard to find. I'm going to divide by 5. And you're like, Mrs. Tabrizi, I got 2 also. Okay?
Okay.
Yeah. Plug it in. Check. Tell me if it works.
It probably doesn't.
Plug it in and check. Question mark. Yes.
But you can't have a -3 equals the square.
There's your trick, guys. There it is.
Imaginary.
Can you, okay, 5x minus 1 equals, can you plug in to a square root and get a negative number? No. No, that's a trick. Because you got 2. Guess what? You didn't do anything wrong. You just missed the extraneous solution.
So there's no solution.
So in this particular case, there is no solution. How do you tell? Well, you can look carefully at each line and make sure that it makes sense. This one, I can pick up pretty easily because square roots cannot be negative.
A cube root. If it was a
Cube root's fine. Square root's not fine. So I'm going to check it. 10 minus 1, so I get 9. So 8 times 2 times 3, oops, sorry, plus. 8 plus 6 is 14, which is not 2. And so you have to cross this out and say no solution. Which brings us to our first vocab word, extraneous solution. Extraneous solution. Solution that solves algebraically but does not check. Right? It's a false positive. You're like, I think it's an answer because I solved for it, but it does not check.
So no solution.
And so you have to cross it out and write no solution. Now, are there ways to pick out extraneous answers? Yeah, you just have to know what to look for. What did I look for? That square root being negative because I know that can't happen. Yeah.
So do you even have to multiply it by the
No,
half?
if this were me solving on a test, I would expect you to stop above the green line. I would not expect you to solve after you realize there is no solution. I would stop. And if you notice that here, that's fine. But I would also want an answer. No solution because the radical cannot be negative. Right? I would need a reason to go with the no solution unless I saw you give me some reason for saying no answer. But yeah, I would expect you to stop right here. Be like, no, none. Okay? Now, sometimes extraneous solutions are harder to pick up. And sometimes you do have to check it just to be sure. Okay.
Oh wait.
Yes?
So, but what if it was -2? Then it would be -2. root
No,
of-
doesn't matter. A radical cannot equal a negative number.
I know, but if you multiplied it by negative.
Oh yeah, then that would work. Okay, let's do our last example for today. Okay. Root 3x plus 2 minus 2 root x equals 0. Oh, it's different. We have 5 minutes. We can do it. This is our last example today. I have more than one x. Means I can't isolate. I don't even have like terms. I can't add anything. So I'm going to write 2 powers or 2 properties over to the right. Okay? I'm going to write two properties. A plus B squared equals okay. There are my two properties for powers. Notice that one of them has a plus. That means FOIL. Notice that the second property, it does not have a plus, and that's when you get to distribute your exponent. Okay, right? Properties that have a common mistake here. If I look at my equation, I have root minus 2 root.
Oh, you can do the first one.
I would like to turn this into something I know how to solve. Yes?
Do you square both sides?
You can square both sides. Okay? Now, don't do this yet. What's going to happen if I do this?
Yeah, turn to
Hold on, hold on. Okay. Yeah, yes. Can you do something else to make this easier?
Plus 2 root x to each side.
Yeah, let's maybe not do this, and let's add this 2 root x to the other side. And then try squaring. Okay, do you notice how this turned into the nicer exponent property? Oh yeah, that second property is a lot easier. Please be careful. That's why I said put parentheses. When you're doing your inverse operations, parentheses so that you do not miss distributing when you're supposed to.
Oh, and then you can.
And now it's super easy. 3x plus 2, careful. It's a 4 in front, guys. It's a 4 in front. 2 squared is 4. And then I get basically x equals 2.
And then do you have to check?
I'm going to say yes. Before we finish solving, we'll come up with a better way than just plugging in to check our answers. But yeah, so we get root 6 plus 2 minus 2 root 2. And so it does check.
Are you supposed to